Okay, we're out in the flow lab today, and we're right next to a new machine that is going together here. It's a Mustang toolbar in a 2-point mount, and the purpose of our discussion today, is to review the Mustang openers. And Al and Stephanie are out here. Jerry and Stephanie are out here today to help us explain how these Mustang openers go together. And I think as we progress, we'll go into some of the details of the system. What we see right now is P51Cs and P51 CUEs. And these openers are built for specific needs. This opener is normally with a 24 or 25 inch blade. This opener CUE is with a 26 or a 28 inch blade. Both openers have similar castings, as you see right here. The spring design that allows the opener to spring up and down as it goes through the field. The upper links are a little different. The CUE has a much stronger upper link as compared to the C, which has this. Okay, well, let's have a quick review into the Mustang technical manual. And Mustang openers are designed to go deep. They go in about 7.5 inches in depth and even deeper, but typically about 7.5. They inject 3 products into the soil, and most of the time they're injecting 2. The points that we'd like to go over, of course, is that there's virtually no soil disturbance with this opener. As shown here, going into wheat, it makes a surgical cut. The opener needs to be adjusted in the soil, and that adjustment is done primarily at one point, and that point is the injector foot. And we see that injector foot here. And so I think what we'll go ahead and do right now is take a picture. So at this point we're going to go ahead and adjust the opener, and Stephanie's going to help Jerry reset the opener with a slight overlap. Now we like to have this overlap here showing on the blade, just right up on the edge of the blade, and this helps create the vacuum. So let's go ahead and break these bolts loose, and we'll make This rocker arm gives the opener a slight tilt, and we need to rock it just a little bit to get it into position. You want to hold that? There's 3 bolts that need to be loosened, and the upper 2 large bolts are very substantial, and then there's an actual safety bolt that's a 3/8 bolt. And it's, once again, to slow everybody down to think about what they're doing. That safety bolt is just there simply to make the final adjustment or to do a tie down initially. So Jerry's going to go ahead and he's going to rock it back. As you can see, that's a pretty open position. That probably won't work too well. And then he brings it up against the blade. And that's about right, just a slight 3/8 overlap on the blade. And you lock down the small bolt first. Into position. Now the big ones get tightened down, and they have swedge type nuts on them, so they pull up tight. This adjustment normally has to occur about every 1,000 to 1,500 acres on the big 60-foot machines. There's the final adjustment. And you can see that the opener now has been okay. Okay, let's call that good. We got two more adjustments up here. These two are the spacers. Those don't. That doesn't have to move. Just the upper two. Okay, now we're going to readjust the injector foot. It's actually a foot, and we're going to move it forward a little bit and back a little bit. And the reasoning why we need this adjustment is to open and close the gap and yet keep this angle of injection down into the slot. And so you need a gap up in here of about 1.5 inches to 2 inches to let the crowns get out of the way, the root crowns. And so we slide this all the way forward. In this particular case, you can see where our bolt hole has mounted. We're going to go ahead and slide it forward. Go ahead, Jerry. And we get that slight overlap on the blade, and then we'll pull her up tight. Now you notice that this is a single edge blade, and so this is actually in the shadow of the blade as it's running in the soil, and it doesn't run deep. It just runs at about the 2-inch line. It never goes any deeper than this point right in here where you see the carbide and the bit. That's the depth that it runs at, and so it shoots it on down into the bottom of the slot in a vacuum. The adjustment that needs to be made as the blade begins to peel off 1 inch or 2 aware is that the tool holder arm can also be moved, and it can be moved forward, and that's why we have this adjustable tool holder link up here to change our geometry. So let's go over to the other side, and let's go look. The tool holder has some adjustments that can be made as the blade begins to wear. There are two positions. This is the lower position and further back. There's an upper position right here, and it's a little more forward. And so as the blade begins to wear, we need to utilize all that adjustment that's possible in the injector foot, which is about almost 3 inches. It can be moved back and forth on this foot here. So in order to facilitate that and to help it out, we have another hole right here. These mounting brackets here are used also to readjust the geometry of the upper link. So Jerry's going to go ahead and remove this nut and bolt, and we're going to just show you that there's this hidden hole back here. There's also a hardened bushing in there. You probably noticed that hardened bushing. And we're going to have to pull this down just a little bit more. But this hard bushing is replaceable. And it's not required to grease it. It doesn't move very much. It's a very subtle movement down in there. But it needs to be hard to run for endurance. Here you can see the second hole up in here. And so that's the forward hole, what we call the forward hole. There's the hard bushing. This bolt comes out, hard bushing goes in there to move to the front hole. And then this upper link can also be changed. Okay, we'll go back together. Okay. Yeah.
I don't know, I wasn't paying attention. I haven't built a COE in about Coon's age. Down real fast.
Yeah. Okay. So once again, the tool holder can be relocated into the front hole. The upper link can be changed in order to get the right geometry for the injector foot. The injector foot is a foot, it's not a shank, it's not a knife, it's a foot, and it simply runs in the shadow of this single edge blade. And we normally leave them just a little loose, pull them up as tight as we can get them, and then maybe back it off one castle nut turn. Hey, right on the money. There you go. So there's about 30 thousandths of slop in the tool holder, so gives a little bit of free movement. These Mustangs have high pressure injection, and you can see the injection points are here, here, and here. 3 points, and this setup allows us to place 3 products into the soil simultaneously. What we'd like to point out that these are threaded TIOs. They thread in and thread out, so if you need to make some major changes on band spacing or have a specialized product that requires a little bit different orifice, you can change it. Another part of the mystery is that the orifices work with very high pressure delivery, so it gives us a broad range. It's like 350 psi of injection pressure. There's little side plates here that mount alongside, made out of spring steel. And this is a chrome insert that is replaceable chrome insert. So this is replaced every now and then as the conditions allow. We go in and replace that insert to get more wear life. The insert is made of chrome, and it protects or gives additional protection to these orifices over time. The orifices are also hardened, glass hard, and they're a special hardening type stainless steel. The injection lines come up and through the back here and come up, and we see the check valves here in the back. This is an ARIG check valve, it's 20 psi. Sometimes we'll have 2 check valves mounted inside of this check valve guard, and that's to run 2 different liquids along with anhydrous ammonia. And then the line is held securely by this strain relief clamp, and it goes in this black spiralite material. And in this particular case, there's 3 lines, 2 yellows and a black installed, so this is a liquid injection system with NH3. So gyro counterweight, this is a wide one, this is a 4-inch gyro counterweight. Bolts, 26-inch blades, they're single edged on one side, back about 4 inches, slightly compounded in here. There's also a slight edge on this back side, so this allows it to go into the ground with ease and not lift soil out. The cross shaft bearings are made from fiberglide bushings. These are the fiberglide bushings that are located up in here. And these are the same bushings that are used on a landing strut on an aircraft. There's also fiberglide bearings in the vertical shaft. So this vertical shaft has two of these fiberglide bearings mounted in here. And then this is sealed up twice. We have a face seal involved right here. Provides a lot of the thrust action and face sealing. And then there's an internal seal, and it is a triple lip seal that goes inside this bearing housing. Also of interest is the metal face seal that we use here on the cross shaft, and so it's sealed on both sides, and then it has a metal face that it runs against to allow this constant vibration up and down as we're going through the field. And of course it has a big take-up on it. So this is the lower swivel unit that gives us this action of swiveling and allowing this injector foot to move up and down as we go across the land. And of course, one of the advantages of this design is that as we hit rocks or cut stumps or sticks, this injector foot actually slides clear to this point right here. So it gets protected so that the rocks cannot hit the injector foot. So this imperfect parallelogram allows the injector foot to move clear up to here as this moves up and out of the way as it strikes rocks. The counterweight is a very key part because it gets the weight down low and gets a dynamic rolling action on the cutting edge. And that allows this to go in very deep. As you can see here, we're running about 7.5 inches in depth with this particular opener. The blade is a 1/2 inch thick, and it's made of manganese steel, hard material, which allows us to get exceptional wear life. And it's just barely machinable to get this nice edge. Chrome shaft provides the adjustment to the upper clamp assembly. And the upper clamp assembly is designed for 4x4, 6x6, 6x4, and 7x7. So the casting's very universal. And then it's sealed up in 3 locations, top and bottom, for extra life. This gives us the ability to adjust this unit's height when we're in the field, or if we move it to another machine or toolbar. We get a lot of flexibility in this adjustment. There's also a series of threaded screws that allow us to adjust this up and down if we need more mechanical advantage to raise and lower the opener. On the back side of the opener, you're going to see some more feature here that's pretty nice. We actually carry another counterweight on this CUE to give it 400 total pounds of weight to penetrate into the soil. We also use a standard industry design retainer plate to hold the spindle shaft. So the spindle shaft can be shimmed or adjusted in and out to hit the true center line of the opener. And of course the design is such that the dual cone floating ring seal is usable, and so these hubs do not require grease or maintenance. Have a little drain port here. If you want to drain the oil out, you can see this particular drain port right in here. This is the dual cone seal retainer right here. Dual cone seals are very common in Caterpillar equipment. It allows the cat to get down in the rivers and the creeks and run without damaging the bearings. Actually, we pressure check these at 95 psi before we ship. 75 psi. So the hub is rated at 3,300 pounds, runs in oil. It's a pinion bearing, which means it has a K factor of about a 45-degree angle, so it can take as much thrust, load, as down pressure. Optimized Timken bearings only are used in the design. Domestic Timken bearings, along with a take-up nut that allows us to set this blade with basically only about 1 to 2 thousandths of run out in the blade when it's all set up. So carbon blades would not work. We've tried all that, been through the carbon blade thing. Actually, very important to pay attention to the blade technology. Pay a little bit more for a high quality blade, and then it'll cut and go in with less horsepower, and it'll seal nice. And the high pressure injection of the opener allows this great sealing, and has been producing these top yields in the Great Plains. And of course, we're trying to form triammonium polyphosphate. We do form triammonium polyphosphate with these toolbars. And the power of the nutrient package and the uniformity is also expressed in the depth of the band. So banding in deeper gives us a little bit more. This is the C series. This is the lighter version of the opener, and more very popular. It's either in 24 or 25 inch. It also has a rolling counterweight that goes on the side here, has the same hub, can have a similar blade but not as big. It does not have the replaceable chrome insert, but it can be added if you so elect. And it has a little lower cost tool holder design, which has to be implemented in order to keep the costs lower. So there's less weight in this opener. Totally loaded up, it's about 302 pounds. And this one is about up to 425 pounds per opener. So it takes a pretty heavy toolbar to carry these openers in the field. And so we've had good success with the Mustang and raising great crops and working in very difficult conditions. Our initial discoveries have been over 5 years now. In rock-strewn soils, we've had to bush up a little tougher, make it better to handle rock-strewn soils. But in the typical Midwestern Great Plains soils, they work very, very well. Thus, we have 4 models to pick from. And so for small farmers that are doing 500 to 1,000 acres a year, we have the B and the A series, as well as this C series. For the guys that really have to cover a lot of acres, we recommend this CUE unit, which allows them to go up to 8,000 acres in 10 days and stay in the tractor seat. That's our best record yet to date. We're hoping for even better acres over time, but big machines, big acres to cover, want to get it on absolutely uniform, get it in deep in the root zone, go into growing wheat. If you want to side dress, pre-plant, this Mustang opener has really made a difference. Okay, well, it's great to explain this opener and how it does perform in the field. I want to point out that there are a lot more differences that I haven't talked about between these two openers, and we have a manual that we've produced, and we expect our owners to read through this manual, get all the technicals of it. There's a complete parts section in the back, and also a maintenance section regarding the hubs, spindles, some of the hard bushings, etc. So any producer that would like to get a little more technical on the unit will realize they can order these parts and service manuals to go with their units. Stephanie and Jerry have worked very hard to make this project a success, and they're certainly willing to work with you if you have any questions about how the opener operates. Thank you.